Welcome to Midnight Coding. Today we'll solve LeetCode problem 2286, invert a binary tree. This is a tree type problem, but before we continue, please like this video and subscribe to the channel as it'll provide you with abundant luck on your upcoming job interview. And it also encourages me to keep making educational videos like this. This is an easy problem as it's only less than 8 lines of code, but I'll give you a quick overview of why the solution works, and then we'll code it up in Go and Python. So what we want to do in this problem is that to take this tree, we want to transform it into this one. And the idea behind it is very simple. So what we are going to do is that we're going to take the left side and the right side of the root, and then we're going to swap them. And then after that, as you can see, 4 has 7 as its left node, and 2 as its right child. And that's what we want to do. And then we're going to treat 4's children nodes as a root node, and we're going to keep reversing until we get 9, 6, 3, and 1 in this order. So as you can see, 9 is going to go to the left, and 6 is going to go on the right, and 1 is going to go to the right, and 3 is going to go on the left. It's really easy to code it up, but basically the idea is that if you want to code it up yourself, you have root, and then you have the left and right children. Basically, what you're going to say is that left and right is going to equal to right and left to swap the children. And you keep doing it iteratively where you make recursive calls, and then that should be it. Now I will show you how to code it up in Python and Go. So here's how to solve this problem in Python. Basically what we're going to say is that we get root as our input parameter. So we're going to say root.left and root.right equals root.right and root.left, as we talked about in our drawing explanation. So it's going to swap the left and right children. And after that, what we can just say is that we can just make this a recursive call, and we're just going to say invert tree, and we're going to invert the left side, and then we're also going to invert the right child. And after that, we can just return the root. The root is not going to change at all. It's going to, for example, in this case, it's going to stay 4 as is. And if we just return 4, then after these calls, it'll already be converted into what we want as our output. One thing to note though is that when we say root.left equals root.right, and when you call this invert tree at root.left, let's say this root was 2 and root.left is going to be 1, right? And let's say we call this invert tree at this one again, but we don't have any children at 1. So what do we do at that point? So we don't do anything at that point. So to avoid any errors, we can just return none if that's the case. And the way to do it is that we can say if not root, then we can just return none, because we don't want to do anything if there's no children nodes. And let's run it to see if it works. Okay, so we gotta call it like self.invert tree because it's within class solution. Okay, now let's run it to see if it works. It does. Let's submit it, and it works. Now let's see how to solve this in Go. The way we solve this in Go is just the same way we would solve it in Python. So we are going to say that if there is no children nodes, we're going to return none. So we're going to say if root equals to none or nil, then we can just return nil. And then we're going to say root.left, root.right equals root.right and root.left. And after that, we can just call this invert tree function, again, iteratively, on the left side and the right side as well. And after that, we can just return root, and that should be it. Let's run it to see if it works. Yes, it does. Let's submit it. So this is how you invert a binary tree in Python and Go. So I hope you liked this video. If you did, please like the video, as it encourages me to keep making videos like this. And if you have any problems you want me to solve, please leave a comment below, and I'll get it done as soon as possible and no later than a week. So see you in the next one.